Okay, let's review what is a function and what is not a function. So anything can be a relation. So under the umbrella of a relation, we either have representations of functions or those that are not functions. So the big idea is a function is a relation where each input or x value has only one output. So again, our focus is the input values, the x values. So we're going to go and ask, is there only one 3 in this list? Is there only one 6? And so forth. So if none of these x values repeat, then we know each of these has their own one output. Now, it's okay if they all go to the same output. It's kind of like a street address. It's kind of one way I look at functions. If I put an address on an envelope and mail a letter, it's going to go to one house in this world. However, there could be several people living in that house, but that one address goes to one house. So number one is a function. So I'm just going to put F for function. Number two, again, we're focusing on the x values, and I'm going to go and see if I have any repeating values, and I do. So we have this 4 with an output of 2, and then it also has an output of 8. So if I mailed a letter and it could go to one house or a different house, it's not very functional, okay? So functions are predictable. You know the outcome. So this is not a function because this 4 has 2 separate outputs. So we're going to say not a function. Number 3, again, we are just scanning the x values and none of these repeat, so each input has its own unique output. Number 4, I can see that the 7 has 2 different outputs. It has an output of 17 and 1, so this is not a function. Number 5, when we have a mapping, your first oval is the input and the second is the output. So we can see each of these has exactly one output. They have one arrow coming from it. So this is a function. Number 6, this 3 has 2 separate outputs. I don't even have to know what they are, but when we have 2 different arrows coming from that, then we know that this is not a function. Number 7, each of these inputs has one output. It's all going to the same place. You could say like the same house if these were represented mailing a letter, and that's okay. So this is a function. Now let's take a look at graphs. And we studied the vertical line test. So if a graph passes the vertical line test, it is a function. So the vertical line test says if I draw a line, a vertical line, and it only can intersect at one point no matter where I draw the line, then it is a function. This means each input only has one output. Number 9, we can see if we draw a line all the way down this one, it's going to hit every point. So it's definitely not a function. Remember, the vertical line is the only line that doesn't pass the vertical line test. So it doesn't even pass its own test. Number 10, we can see that the vertical line test is passed because it only can intersect at one point. So this is a function. Number 11, the horizontal line is a function. And then we have this circle, and we can see that it's going to hit at 2 points, more than one. So this is not a function. And 13, this part of the graph here makes this not a function. Now let's talk about just some ideas if we don't have a graph or we don't have a function table. So it's all about, so you're just going to ask yourself about the input. So an email address, if I type in an email address, how many different individuals is it going to go to? It's just going to go to one. So this can only go to one person. So this idea is a function. One email address goes to one individual. Now 15, we switched the ideas around. An individual, So if I ask you for your email address, maybe you have more than one and you don't just have one email address. I know I have several. So Ms. Thomas has several email addresses, and so therefore this is not a function. A driver. So does a driver have a single driver's license, or could you have more than one? Well, I gave the illustration, or give the illustration, that I have a driver's license that's current and I have an old one. It's not valid, but I still have it. Or someone could have a driver's license for a special vehicle plus just a regular driver's license. Or maybe we move out of state and we still have our current driver's license and the new one. So a driver may have more than one driver's license. So I'm going to say this is not a function. Number 17, so if I found someone's driver's license, how many people would it belong to? It would just belong to one person. So this is a function. So let's just say we're at a school and we have a locker combination. So each locker has a unique combination. So a locker combination will only be assigned to one student. So this is a function. Now, what about a student? Could they have more than one locker combination? Maybe they have more than one locker. Maybe they have a hallway locker, but they also have like a gym locker. So a student could have two different lockers. So I'm going to say this is not a function. And I hope this helps.